Hello everyone, this is Lau and welcome to my Google Hang report of my blog for information. Daniel K. Moran says, you can have data without information, but you cannot have information without data. Today, I'm going to explain block 4 about two main points, data modeling and database. In my presentation, first, I will talk about data modeling. Then I will talk about database and how this technology affects users' lives. Data modeling. Data modeling is the act of exploring data-oriented structures. Like other modeling artifacts, data modeling can be used for a variety of purposes, from high-level conceptual models to physical data models. From the point of view of an object-oriented developer, data modeling is conceptually similar to class modeling. With data modeling, you identify entity types, whereas with class modeling, you identify classes. Data attributes are assigned to entity types just as you would assign attributes and operations to classes. There are associations between entities, similar to the associations between class, relationships, inheritance, composition, and aggregation, and all applicable concepts in data modeling. Traditional data modeling is different from class modeling because it focuses solely on data. Class models allow you to explore both the behavior and data aspects of your domain. With a data model, you can only explore data issue. Because of this focus, data modelers have a tendency to be much better at getting the data right than object modelers. However, some people will model database methods, store procedures, store functions, and triggers when they are physical data modeling. It depends on the situation, of course, but I personally think that this is a good idea and promotes the concept in much simpler terms. It focuses on the type of data which is required, the way it has to be organized, and the manipulation process which will be performed on the data to provide a complete and accurate structure for data within the information system. An example of data model is like the architecture building plan. Moreover, a data model is free for hardware and software constraints. It focuses more on how the users will see the information rather than how the database will see it. In addition to this, it is like a link between our concepts of real life and the representation of those concepts physically in a database. Data modeling would tend to be one of the most time-consuming part of development process. A further instance could be building a database without a model is like building Harbour Bridge without an architectural plan. The main motive of data modeling behind database instruction is to ensure that data objects are completely and accurately represented. This is because data models um, use easily understood notations and ordinary language that it could be used to communicate with the end users. Looking at its importance and benefits from the designer's point of view, this is still enough and will be used by developers as a plan for building a physical database. The information which is in the data model could be used to identify primary keys, foreign keys, relational tables, stored procedures, and triggers. In the long run, a poorly designed database will require additional time. Moreover, if a database is created without sufficient and cautious planning, it could result in a database which omits data to create important reports, lead the results to be inaccurate and inconsistent. This could also be incomparable to accommodate for changes in the requirement of users. Database. Database, also called electronic database. Any collection of data or information that is especially organized for rapid research and retrieval by computer. The collection information could be in any number of formats: electronic, printed, graphic, audio, statistical combinations. There are physical, paperprint, and electronic database. A database could be as simple as an alphabetical arrangement of names in an address book, or as complex as a database that provides information in a combination of formats. The example would be phone book, address book, and census bureau data. Databases are structured to facilitate the storage, retrieval, modification, and deletion of data in conjunction with various data processing operations. A database management system extracts information from the database in response to questions. Databases are older than many people realize. By the mid-1960s, businesses and governments were using simple databases for storing and retrieving information on storage systems. In the 1970s, the relationship database model was developed, and much for the language used in the model database programming was developed during this time period. SQL databases have dominated the field ever since. Computer can perform calculations far faster than humans, and they use programmed logic to make decisions. However, computers are also capable for storing a tremendous amount of information, and the amount of data computers can store continues to increase. Databases are at the forefront of making this information available to programs and to computers. Most medium and large companies rely on databases for storing customer information. They also use them to store accounting information. Researchers use databases as well. Some of the largest databases in the world store weather information. There are simply too many weather data points for humans to analyze, and finding signs of small but significant climate shifts would be impossible without databases. In conclusion, I would love to review all the main points that I mentioned: data modeling and database. I hope I explained two main points clear for my audience, and thanks for listening.